in here we have a triangle and we're given that PS bisects angle QPR. QPR. Bisects meaning that it forms two congruent angles as a result. XT is a perpendicular bisector of PS. So XT is going to be perpendicular to PS and also is going to bisect PS into two equal parts. So PX will be equal to XS as a result. Okay, so we have to prove that ST is parallel to QP. So the first thing that we do, we copy down the given part and explain it as a given, give its reason as a given. Then the next part that you should see immediately is that angle QPS is congruent to angle SPT. Okay, and how do we get that from? So let's see that graphically. QPS, so this angle, is congruent to SPT. So obviously this comes from the given part that PS bisects angle QPR, right? Bisects means that it forms two congruent angles as a result, right? So this reason is the definition of an angle bisector, right? In this case, the angle bisector is PS. So now the next step would be to notice that PX is congruent to XS. And also the measure of angle PXT. Okay, so let's take a look at that. So PX is congruent to XS, and that's the result of the perpendicular bisector, right? Bisector means creating equal subsegments from the given segment PS, right? So PX is congruent to XS. Now the measure of angle PXT, this one is equal to the measure of angle TXS, and they're both equal to 90 degrees. And where do we get that from? We got it from the perpendicular bisector part, right? Not just the bisector, but perpendicular. Perpendicular means that obviously there will be perpendicular relationship which creates 90-degree angles. Okay, so that's why these two angles are 90 degrees each. So the simple reason for that is to say that the definition of perpendicular bisector. Okay. Now, the next step is so what are we trying to do? We're trying to show that the ST is parallel to QP. Okay, so notice that if we show that for example these two triangles are congruent, we can use its side relationships and find corresponding parts, and then that way we can estimate what's going to be happening with the relationship outside, right? So we're talking about these angles being somewhat related, and we're going to get to it and we're going to explore how. But first we're going to use these two triangles to find relationships that we're going to pass on to this triangle later. Okay, so for that, notice that we already have what? We already have one pair of sides that is the same in these two triangles, that is congruent. We have PX and XS, right? We also have a pair of angles, right? These both are 90 degrees. Now we have the third part available, right? In order to determine congruence of these two triangles, we have the shared XT. So we're gonna set XT being congruent to itself. And the reason for that is the reflexive, of course, reflexive property of congruence. congruence. So now we have, beautiful, we have now a side that is shared, right? We have the second set of congruent sides, these two are congruent, and we have the same angle measure, 90 degrees here and there, right? So we already have the side, angle, side congruence, right? Side, angle, side for these two triangles. Side, angle, side, right? So we can easily, comfortably determine that PXT triangle is congruent, not just similar, but congruent to TXS. Okay, and that's the side, angle, side postulate of congruence. All right, so now that we found that these two are congruent, the next step would be to see that angle SPT, this angle, will be congruent to that angle, because these are the corresponding parts of these two congruent triangles, right? So SPT is going to be congruent to angle RST. I'm sorry, PST, right? So these two angle measures are going to be the same, and these angles will be congruent, right? So PST. So the reason for that is going to be, again, the corresponding parts of congruent triangles are congruent. CPCTC, that's the short way of saying it. Right, saves you a lot of space if you write these all out as words. So now the next step is to notice that measure of angle QPS is equal to the measure of angle SPT. So let's find that graphically. QPS is equal to the measure of SPT. Right? And how do we know that? We knew that because before we said that QPS was congruent to SPT. So thus their measures must be equal, right? From line 2 here. Right? So the simple explanation for that would be the definition of congruent angles. Right? Because if they're congruent, then their measures must be equal as well, and this is all in the definition of congruent angles. Now the next part is to show, using substitution, that measure of QPS. So now we show that the QPS, this one, we showed so far that QPS, this angle measure, is equal to this angle measure. But remember, this angle measure was equal to that angle measure, right? Because the SPT was congruent to PST, right? As we showed in line 6. So now we can substitute. We can say measure of QPS is equal to the measure of angle PST. Okay, we probably need one more line just to show that angle measure of, why don't I do that? I want to perhaps not skip a step if it's possible, just to be sure. So measure of angle SPT is equal to the measure of angle PST. And again, this is the definition. I'm going to use the same. So this is the same as reason 7, the definition of congruent angles. Right? I'm just saying that because, just to be sure, because we didn't have measure of angle PST is equal to the measure of SPT. But it's some teachers will not mind if you skip it, but I just want to make sure that we don't, because we're going to use exact substitution. So now what you're going to do, you see these lines 7 and 8, transitive properties. You can use transitive property and work it out, right? You will not need a substitution, but rather transitive property. Notice that in this case, measure of angle SPT repeats, so you can omit it and set the outer guys equal. measure of QPS is equal to the measure of PST. So let's look at that graphically. So that's again the transitive property of equality, not congruence, but equality in this case, right? Because we're talking about equal sign and not congruent sign. Transitive property of equality. Okay, so let's see that graphically. So QPS, that's that one, is equal to the measure of PST. PST, beautiful. What does that mean, by the way? Notice that these are alternate interior angles that happen to be also equal. Now, when they're equal in their alternate interior angles, these lines will definitely be parallel. Otherwise, these angles would not be equal, right? The alternate interior angles need not be equal. Sometimes they're unequal, but they're still alternate interior angles because they're in the opposite positions. But since they're equal, that means these guys are locked in parallelism. They're parallel. There's no way they're not parallel, right? So how do we get there? So first, the 10th step should be that QPS, angle QPS, and angle PST are alternate interior angles. Okay, so the reason to say that is just definition of alternate interior angles. Okay, the definition states that they will be on the opposite ends basically of a transversal line. In this case, PS would be treated like a line segment on a transversal line. Okay, so these two angles, alternate interior angles, would be on the opposite positions, on the opposite sides of this transversal line segment. Okay, so finally, now that you show that these are alternate interior angles, you're ready for this final step. So ST is parallel to PQ, and the simple reason for that is that the QPS and PST are congruent. Okay, so basically you show that the QPS and TSP, PST, well, whichever way you want, PST are congruent. As long as they're congruent, these two will be parallel. Alright, so this is it. So I hope you enjoyed it. Thanks for watching. See you in the next video.